Hi everyone, welcome to my presentation. I'm Pei-Yan Zhang from the Hong Kong University of Science and Technology. In this talk, I will present our work, Attention Mixture, which leverages multi-level user intent for session-based recommendation. I will briefly talk about the background. Then I will introduce our motivation and our model architecture, how we boost its performance, and how we make it more practical. Recommender systems have been widely deployed in real-world applications. However, the success of the recommender systems heavily relies on the data that might contain private and sensitive information. For scenarios where user information is unavailable due to privacy protection, conventional recommender systems often exhibit poor performance. However, to build the trustworthy recommender systems, the safety of the privacy must be guaranteed. Recently, users increasingly value their privacy and prefer not to log in when using online platforms. For example, on Google News, the ratio of the unlogged-in users to logged-in users is around 8.47 to 1. Which highlights the importance of the anonymous session-based recommendation. Here, a session is composed of multiple user-item interactions that happens in a continuous period of time, such as a basket of products that purchased in one transaction visit. By taking each session as a basic input unit, session-based recommender systems are capable of capturing both a user's short-term preference from her recent sessions and the preference dynamics reflecting on the change of the preference from one session to another for a more accurate and timely recommendation. However, as the user information may be unavailable due to privacy concerns, the longer-term user preference may be unavailable either. Therefore, it is challenging to model user intentions from such small sets of interactions. Here I show a roadmap of session-based recommendation models from the RM-based to CNN-based, and recently there has been an increasing interest in utilizing various elaborately designed graph neural networks to capture the pairwise relationships within sessions, similarly suggesting that the design of a more complicated model is a panacea for improving the empirical performance. However, these models achieves relatively marginal improvement with drastic growth in model time complexity. In view of this phenomenon, a meaningful question naturally arises. Are those graph models under or over complicated for session-based recommendation? To answer this question, we try to dissect the GN-based session-based recommendation models and analyze their importance in this task. Typically, these models for session-based recommendation can be divided into two parts. The first part is the GN module, which consists of the graph propagation weights and the GRU weights. The second part is the attention-based radar module, which consists of the attention pooling weights and transformation weights. Then we apply sparse variational dropout technique to compute the density ratio of each parameter and measure its importance during training. The density ratio is the ratio of the entries of the parameter weight that is larger than the threshold value. The left figure is for the GN module. As GN has many parameters with random initialization, there will be a lot of updated knowledge at the beginning. So here we can see there is a fluctuation of the density ratio of the graph propagation weights during the first few batches. However, this density ratio will approach 0 when the training becomes stable. The right figure is for the radar module. We can observe that the attention pooling weights could preserve a relatively higher density ratio as training progresses. we can observe similar phenomena on other datasets and for other graph models. Given these results, we empirically find that the GN parameters seems redundant in session-based recommendation. Inspired by these findings, we come up with the following guidelines for a much simpler yet effective model for session-based recommendation. That is, we remove the GN module and focus on the attention-based result module. However, as the GN is responsible for the model reasoning, once it is removed, the result module itself should take more responsibility in the model reasoning process. So here comes the challenge. How to design a radar module with a stronger reasoning ability? Well, according to the psychopathology, human reasoning is by nature a multi-level information processing procedure. For example, by synthesizing the bottom-level items that interacted by Alice, we may obtain the higher-level concepts such as the furniture and decoration and the wedding supplies that help identify Alice's interest. We strive to operationalize this insight into our radar module design that reflects the human reasoning process. However, finding such high-level concepts is non-trivial, as simply enumerating all possible high-level concepts is infeasible for large-scale recommender systems and may introduce irrelevant noise that harm the performance. So we face the new challenge: how to achieve informative high-level concepts efficiently. To address this challenge, we incorporate the session-based recommendation-related inductive biases, namely the inherent priority and the local invariance, which can significantly prune our search space. The inherent priority emphasizes on the contributions of the last few items for modeling users' preference, while the local invariance indicates that the local order of the last few items is unimportant. Therefore, we utilize the groups of the last few items with different lengths to generate the high-level concepts. Here, the last few items indicates the inherent priority. The groups indicates the local invariance, while the different lengths indicates that we consider the multi-level high-level concepts. So we present attention mixer in this project. It is a plug-in model that can be incorporated with various encoders. For the initial situation, given an input session, we first gather its embedding of each item from the embedding layer. Here is a key component of attention mixer. We will apply the linear transformation on the group representations to generate the multi-level user intent queries. Here the Q1 is the instant view attention query, while the others are the multi-level attention queries with different receptive fields and local invariant information. Then we utilize the generated queries to attend to each item of the session and obtain the session representation. So for the offline evaluation, we consider 3 benchmarks. The Diginetica is for the e-commerce transaction dataset. The Grala is for the social networking dataset. And the Last.fm is for the music recommendation dataset. We compare with the CNN-based, RN-based, GN-based, and radar-based baselines. We find that attention mixture outperforms baselines on all datasets in terms of the accuracy and efficiency. We also incorporate attention mixture into the baselines to analyze the performance enhancement brought by our method. We find that attention mixture significantly improves the model performance with all metrics in all datasets, especially when the K in the matrix is smaller. A smaller K means that the target items stay at the top positions of the recommendation list, which indicates that our model can help the original model to produce more accurate and user-friendly recommendations. We also conduct evaluation studies on the key components of attention mixture, such as the multi-level user intent queries, the inductive biases, and we find that all the components are useful. We also incorporate GNN with our attention mixture component and compare it with GNN with other radar modules, such as SRGNN and GCSAN, and test their performance with the increase of the session length. We find that attention mixture can consistently produce the best performance. We also analyze how the hyperparameters, such as the attention level L and the multi-head number H, affect the performance. We find that attention mixture performs worst when L equals to 1. That is, when L equals to 1, we generate the overall preference with only attend on the last clicked items, while without the raising process brought by the GN propagation part, simply relying on the last item is fragmented, as it lacks the information of the high-level connections between items. Attention mixture has been fully deployed for online services since June 2022, serving around 10 million of page views every day. The online experiments also validate its effectiveness in the real industrial applications. To make a recap, with the multi-level reasoning ability, attention mixture has achieved superior offline and online performance in terms of the accuracy and efficiency. Here are some takeaways. First, sophisticated model architectures might not be the panacea for session-based recommendation. Well, we hypothesize that an advanced architecture design on the attention-based radar module for the session representation is promising. Next, multi-level concepts correlations help identify users' interests. And leveraging inductive biases is a shortcut for finding informative high-level concepts. That's all for my presentation. Thanks for listening.